Okay, I'm sorry I had to cut short our previous video where we were doing some order of operations, but we'll resume here with number 23. So remember, order of operations, please excuse my dear Aunt Sally or PEMDAS, and we just continue working through those, okay? All right, so number 23 here, it looks like we've got an addition and a multiplication. There's not any parentheses, we get to skip that. There's not any exponents, we get to skip that. But we've got an adding and a multiplying. And remember, the multiplying and dividing come first. So we're going to do the multiplication and division first. So 1.5 times 7.6 in our calculator is 11.4. So 4.6 plus 11.4, and then we do the adding. Now watch this little trick here. I've already got the 11.4 and I'm just adding it, so I'm just going to put plus 4.6. And my calculator knew to take that last number and just add the 4.6. Okay? And we get 16. Now, if you want to speed it up and you just want to type the whole thing in originally, 4.6 plus 1.5 times 7.6, your calculator does know order of operations and will follow that. So either way, if you just want to let the calculator do it, that's fine, and you'll get your 16. Okay? Number 24, I really like this one. We see a division and we see a multiplication. And this is really testing whether you remember that multiplication and division are equal levels. We do them as we see them from left to right. So sometimes people say, oh, please excuse my dear Aunt Sally, PEMDAS, multiply and then do the division. And actually, multiplication and division are the same level. We do them as we see them from left to right. So in this case, actually, the division is first. 16 divided by 2 is 8. And then the 8 times 4 is 32. Again, your calculator knows order of operations. So if you type it in just like it was written, it will do the order of operations for you. Okay? Notice that if you had done 2 times 4 first and gotten 8, then you would have had 16 divided by 8 and gotten 2, which would be a different answer. So it is important that we follow that order of operations. 25, what's different about this one is we have a fraction for the first time. That fraction is acting like a division bar, okay? But it is implying that we should work out the entire top, we should work out the entire bottom, and those two numbers are what get divided here with the division symbol, okay? So we can work the top separately from the bottom, okay? On the top, we've got a parentheses and an exponent. Parentheses come first. 9 minus 5 is 4, so 4 squared divided by whatever's on the bottom, okay? The 4 squared is 16 divided by whatever's on the bottom. On the bottom, 6 minus 8 is negative 2. And then you would do your division, so 16 divided by 2 is negative 8. Again, your calculator knows order of operations, okay? Now, if you're using a newer 84 calculator, if you'll push alpha, the green alpha button here, and then y equals, it will say, oh, you want to do a fraction? Do you want it to be regular numerator over denominator? That's what the N and the D stand for, and I can say yes by pressing enter. And then I can just type in the way it looked. So I can make my calculator look exactly like the original problem, okay? If you're using an 83, that alpha y equals doesn't do anything on yours. So in that case, you have to write the entire numerator in one set of parentheses, and then hit the division bar and put the 6 minus 8 in another set of parentheses, okay? So to do it that way, I would say, okay, parentheses, my top is, so I've got an extra set of parentheses around that, 9 minus 5, to the second. So notice what I've done. I put the 9 minus 5 squared in its own set of parentheses, then division symbol, and then I put my 6 minus 8 in its own set of parentheses. And it will do it for me. So it just depends if you have an 84 or an 83. That's how you type it in. This last one here, notice we've got a set of parentheses, but it's inside another set of parentheses. So when that happens, you start with the parentheses, but you work your inside out. So we do this innermost set of parentheses. 2 plus 5 is 7. So I'm just going to recopy every single thing except I'm replacing that 2 plus 5 with 7. Okay, so now I've worked that set of parentheses. Now I'm going to work this outer set of parentheses with the 12 minus 7. So 3 plus 8 parentheses, 12 minus 7 is 5. Okay, notice now I have an adding and I have a multiplying. We said multiplying would come first before adding or subtracting. 8 times 5 is 40, and then we add and get our 43. Okay? Again, your calculator knows the order of operations. So if you just type it in exactly like it looks, you'll get the same answer. Okay? Order of operations just takes a little bit of practice, so I really encourage you on that homework, spend a little time with those, make sure you understand why each one of those homework problems works out like it does. Okay, next page, everyone's favorite, word problems. Okay, now the nice thing about this page is you don't actually have to work any problems. They're just asking you, hey, read through some scenarios, see if you understand kind of the big ideas they're getting at, and see if you can process that, but you don't actually have to do any number crunching, which is kind of nice. My recommendation on this part of the video, you take a minute and read it, think about it, see what you think, and then push play on the video again. So pause the video, read it, think about it, see what you think the answer is. Take a couple minutes and do that, then push play and see if you were right, okay? Because these are probably scenarios that you may not be familiar with. We're just trying to see if you can read something that maybe you're not familiar with. Maybe it's a new type of scenario. This one's about marathon runners. This one's about birth weights of babies. So it may be something that you're not as familiar with, but can you read it and process it and just understand the scenario? You don't have to do any calculations. You're just trying to think it through from a logical perspective and critical thinking, okay? All right, so if you want to try that, push pause and then watch the rest of it and check your answers when you think you have it, okay? All right. A marathon has several hundred runners, so they cannot all start at the same time. Now, if you just stop right there and think about that, marathon, that's one of those really long races, 26-something miles, and there's so many people, several hundred runners, so they can't all start at the same time. They have to kind of line up. And it might take a few minutes after they start the race and the front runners take off before the people at the back of the pack would even get to the starting line, okay? So that means someone might be a mile down the road before the last people even get to start their race. So it seems like that might be a little unfair. They might have actually run the race faster. The people at the back might be the fastest ones, but because they're getting a late start compared to everyone else, they couldn't win. So what they do to account for that, it says, in order to determine the winner, because what if the fastest person was at the back and it took them a while to get started, it says. So a microchip is tied to each runner's shoe. GPS tracks the exact moment each runner crosses the start line, several points throughout the course, and again at the finish line. Okay, so in other words, I may start my race 5 minutes behind you, but if it tracks how many minutes it takes for me to get to each of the cutoff points, they can know the exact number of minutes I was running, even if that's a different number of minutes than you were running, because we started at different times. Then each runner's total time on the course is calculated. So they can say, Beck was out there for 2 hours and 12 minutes. Somebody else was out there for 2 hours and 7 minutes. Someone else was out there for 2 hours and 23 minutes, etc. Will the marathon winner have the longest or shortest total time on the course? So whoever gets the gold medal and wins and is considered the winner and the fastest runner, will they have the shortest time or the longest time out on the course? And of course, whoever runs the fastest finish sooner, so their time is less. Okay, so if we wanted to notice, it said we want to write our answers in a sentence. So I would say something like, the winner will have the shortest time. Okay, so something along those lines. Okay, a big part of statistics is maybe reading an encounter that maybe you've not done. Maybe you've never run a race before, but that's okay. They're explaining how it works, and then we just apply our knowledge and our critical thinking. Okay. 28, a pediatrician. Pediatrician is a doctor whose patients are babies. A pediatrician, or young children, doesn't have to be a baby, it could be a child. A pediatrician takes several measurements of babies when they are first born in order to monitor their health. So So if you think about that, what kind of measurements would the doctor want when a baby is born? Probably, maybe some kind of blood testing, maybe some kind of height and weight of the baby, maybe the circumference of their head, how big their head is, different things like that. And it says, low birth weight can be a sign of problems for a baby. Is the doctor more worried about babies with larger numbers on the scale or smaller numbers? Okay, so if you think about, what does a baby weigh? Maybe the baby weighs 8 pounds or 7 pounds or 10 pounds or however much the baby weighs. And the doctor says low birth weight can be a sign of a problem. So when the doctor puts the baby on the scale, are they going to be worried about high numbers or low numbers? And if it says low birth weight could be a problem, then I'm thinking they're worried if there's low numbers on the scale, because that means they weigh less. Okay? So I'm going to say she is more worried about low numbers, because those babies weigh less. So if there was a baby that only weighed 3 or 4 pounds, that's a low number. That could be a sign that they have to really watch that baby and make sure they're okay. All right, 29. A business records its income as positive numbers when they experience profit and negative numbers when they experience losses. So think about what that means. Profit is how much money the business makes. So if they make a lot of money, they have a profit. More specifically, if they make more money than what their expenses are, because they're going to have expenses. They're going to have to pay their employees. They're going to have to pay rent on the building. They're going to have to buy the materials to make their products. So they're going to have expenses. But if they bring in sales more money than they spent, that's called profit. On the flip side, if they spend more money than they bring in, then they didn't make any money. They have a loss. They lost money because they spent more than they made. Okay? And so that's why it would be a negative number if they had a loss. Okay. Avery and Bart recently graduated from culinary school, that means cooking school, and are each opening their own restaurants. Since they are friends, they decide to collaborate with each other, that means work together, on business strategies to help each other. Avery's Italian restaurant had a net income of negative $7,500. Negative. Remember, negative meant they had a loss. So Avery's restaurant had a net income of negative $7,500 last month due to some heavy expenses for advertising. So he spent a bunch of money on advertising, and his income is negative $7,500. That means he lost $7,500. He spent $7,500 more than what he made. Bart's Bakery had a net income of negative $5,000 last month due to purchasing new baking equipment. So Bart bought some new equipment, so he lost money as well. He lost $5,000. And the question is, which business performed better? Now, they both lost money. Avery lost $7,500. Bart lost $5,000. They both lost money. But their question is, which one did better? Well, whoever lost less money is going to be the one that did better. They both lost money. It's bad news for both of them. But whoever lost the smallest amount of money did better. So I would say losing $7,500 would be worse than losing $5,000. So $5,000 is the better scenario, so Bart must have done better. So I'm going to say Bart's Bakery performed better because he lost less money. Okay. All right. A spark plug needs to have a gap as close to 0.6 millimeters as possible. M means millimeters. In June, when servicing his engine, Abel found that his spark plug had a gap of 0.64 millimeters. In December, when servicing his engine again, he found that his spark plug had a gap of 0.58 millimeters. In which month did his spark plug come closest to the desired 0.6 millimeters? Okay? All right, so spark plug sounds like it's part of your engine, some kind of car part in your engine. So let's kind of break it down here. It says it needs to have a gap as close to 0.6 as possible. So this is what we want. We want it to be 0.6. Okay, in December, so I'm going to make a note over here. In June. In June, when servicing his engine, he found that the spark plug had a gap of 0.64 millimeters. In December, he found that the spark plug had a gap of 0.58. So which month did it come closer? Okay, well, in June, he wanted it to be 0.6, but it was 0.64. So how far apart is that? How much change is it? So I'm going to say 0.64 minus 0.6. Oh, it's 0.04 away. It's 0.04 away from what he wanted. Now notice it was above. 0.64 is bigger than 0.6, so it was above the desired measurement, but it was 0.04 away from that desired measurement. In December, 0.6 minus 0.58, it's 0.02 away. So in December, it's smaller than he wanted. 0.58 is smaller than 0.6, but it was 0.02 away. So their question is not, hey, was it bigger or smaller or when? They just said, in which month was it closest? Well, if you wanted 0.6, then 0.58 is closer because it's only 0.02 away. So it must have been closer in December. So I'm going to say December is closer because it is off by 0.02 instead of 0.04. Okay? All right. And then on the back, these last few problems are actually a few problems to work, but they give us formulas. So what's going to happen a lot in statistics class is we're going to be given formulas, okay? We're just going to take the formulas they give us and we're going to use them, but we have to be able to look and figure out what numbers to put in for each variable so that our calculator can do the number crunching for us using our order of operations, okay? All right, in a statistics class, a student's final grade is calculated by this equation, where G is the final grade, so G in the formula is the final grade, H is the homework average, L is the lab average, so whatever the lab average is, that's what we put for L. T is the test average, whatever the test average is, that's what we put for T. And F is the final exam grade, so whatever they get on the final, that's what goes for F. Calculate Joe's final grade if his homework average was 82, his lab average was 75, his test average was 90, and his final exam was 86. Round to the nearest whole number. So notice these numbers they've given us, homework average, lab average, test average, those are those same variables that they mentioned up there. So we're just going to plug those numbers in and let the calculator do the number crunching for us. So this was our formula, just copying it down. And then I'm going to plug in the numbers they gave me. They said his homework average was 82, so I'm going to put 82 for H. It says his lab average was 75. I'm going to put 75 for L. His test average was 90. I'm going to put 90 for T. And his final exam was 86, so I'm going to put 86 for F. Now, remember me saying on that other video that every time I plug a number in, I like to put parentheses around it, just as a reminder that it's 0.1 times 82 and 0.2 times 75 and so on, okay? You can work this out by hand if you want, number crunching, but we have a calculator. So you can just plug those numbers in just like we wrote down. Okay? And I got 85.4. And they said round to the nearest whole number. So 5 is in our whole number position. 4 will not round up. It will stay where it is. So his final grade is 85. Okay? All right, number 32, a person's body mass index, commonly called BMI. If you're familiar with BMI, great. If not, they're just telling you, hey, BMI stands for body mass index. Don't worry about necessarily what it means if you're not familiar with it, but you can still use the formula that they're giving us, okay? So BMI is calculated using this formula, where W is their weight in pounds. So W is weight, and it has to be in pounds. So if they give you the weight in ounces or something like that, you'd have to convert it to pounds in order to use the formula. And H is their height in inches. So H is height in inches. So again, if they give you how tall a person is in inches, you put that for H. If they give you their height in some other unit, like feet or centimeters or whatever, you would have to convert to inches before you could use the formula. Okay? Calculate Susan's BMI if her weight is 160. Okay, so her weight is 160. That's what we're going to put for W. And her height is, that numbering system right there. That's her height. And if you've never seen this before, 5'6", you're probably familiar with the height being 5'6". The 5 is in feet, and the 6 is the inches. So that's usually how we report height, is saying, oh, I'm 5'6", I'm 5 feet, 6 inches tall. Okay. Problem is, remember our formula wants the height to be in inches, not feet and inches. Okay, so if she's 5 feet 6 inches, we need to know what that is in just regular inches. So we got to think about the relationship between feet and inches, and hopefully you know that there's 12 inches in 1 foot. So for every foot tall a person is, that's 12 inches. So if she's 5 feet, each one of those 5 feet is worth 12 inches. 5 times 12 is 60. So those 5 feet is 60 inches plus another 6 inches. So she's 66 inches tall. Okay, so when we go to our formula, BMI equals W over H squared times 703. They told us her weight was 160 and her height is 66. Her height, 5 feet 6 inches, is just 66 inches. And then we square the height times 703. Okay. All right, now we can plug this in our calculator. Keep in mind that the 160 gets divided by 66 squared. It does not get divided by 66 and then squared. We got to square the 66 and then do the division, okay? So if you're using an 84, you can use your little fraction trick. Remember, it was alpha and then the y equals button, and then choose the numerator denominator, and you can type it in. 160 over 66 squared. Then I arrowed out to get over on the side where I typed my times 703. Okay? Now notice, unfortunately, because I typed in a fraction, it thinks I want my answer as a fraction, and I probably don't. I would rather have a decimal. So what you can do then is you can hit your math button and say, oh, I don't want to convert to a fraction. I want to convert to a decimal. And it'll make it a decimal for you. Okay? Here's a place where the 83 people might have an advantage. The 83 people don't have that fraction key. So they're just going to say 160. They're going to put that in parentheses. They put the top number in parentheses. Divided by 66 squared. Notice my 66 squared is in parentheses to tell the calculator, hey, take the whole 160 and divide it by whatever 66 squared is. And then times your 703. And notice theirs comes out directly as a decimal. They didn't have to say convert to a decimal. Okay, but either way, you're going to get 25.8218, blah, blah, blah. Notice they said to round to the nearest tenth. 8's in the tenths place. The number after it does not round up. So 25.8 is the BMI. Okay, last one here. Christina is concerned that she's not getting enough sleep. Her doctor asked her to calculate the mean number of hours she sleeps for a week. Okay, we're going to talk about this more in Chapter 3, but mean is another word for average. Okay, and average means you add them all up and you divide by how many there are. Okay, and we'll talk more about that in Chapter 3, but mean or average means add the numbers up and divide by how many there are. So since she's doing this for a week, she's going to add up all her sleep for the whole week and then divide by 7. And the reason it's 7 is because there's 7 days in a week. Okay. Sure enough, if you read this, her results are 5 hours, 5.25, 7, 6.56, 5.75, 4.75. Those are 7 numbers because there's 7 days in a week. Okay, so what is the mean number of hours of sleep she should report to the doctor? Write a complete sentence expressing your opinion of whether or not she's getting enough sleep. So we're going to take the numbers they gave us, the 5 hours, the 5.25, the 7, the 6.5, the 6, the 5.75, and the 4.75, and there were 7 of those numbers. So after we add them up, we'll divide by 7. Okay? So I would say 5 plus 5.25 plus 7 plus 6.5 plus 6 plus 5.75 plus 4.75, and my total is 40.25. So for the whole week, she slept 40.25 hours, and we divide that by 7. Now watch this little trick. The last number in there was 40.25, so I just hit divided by, and I say 7, and out comes my 5.75. Now, a word of caution. I've had people before who say, oh, I don't want to do it in 2 steps. I don't want to do all the adding and then do the division. I'm going to just type it all in at once. So I'm going to add them all up and then hit divided by 7. And notice what happens. We got something different. We got 30-something. And if you really think about it, that doesn't make sense. If she was only sleeping, 4, 5, 6 hours a night, there's no way it can average to 30. Okay, well, what happened? So what happened is my calculator knows order of operations. So my calculator said, oh, you're doing some adding and division? Oh, you need to do the division first. So it only divided that very last number, 4.75, by the 7. And that's what got added to the other numbers. So my recommendation is that you type in all the adding and take that result and divide by 7. If you really want to do it all in one step, then you need to use some parentheses. You need to tell the calculator, hey, do all the adding first. So I put all those adding numbers in parentheses to tell the calculator, hey, do all the adding first, and that whole result of the adding is what gets divided by 7. And then it will come out right for you. So do be careful about how you type that in, okay? So this means that her average is 5.75 hours of sleep. So her average is 5.75 hours per night. And, it's kind of personal opinion. If you think that's enough, it said write your opinion of if that's enough or not. Personally, I do not think it's enough. No, I don't think it's enough. But you may have a different opinion on that. I usually think they say probably 7 or 8 hours is about what we need, so that's why I'm saying no. But for some people, that might be enough, and they may say, yeah, it's fine. So they didn't give us a cutoff. They just said, write your opinion.